So let's give them a shot. So part A, we're doing F opposed with G. So that means we're going to do F of G of X. And so we're going to put G of X everywhere. So there's an X in F. So we're going to have G of X over G of X minus 3. And now we know G of X is -2 over X, so we're going to substitute that in for G of X in our problem there. So we have -2 over X over -2 over X minus 3. Any questions on getting there? So once we got that, we got fractions within fractions, so we want to get rid of those. And to do that, we're going to multiply numerator and denominator by what's in the denominator there, which is an X. And so we can write it out. It's going to be -2 over X times X over -2 over X. And that X is going to distribute, so it's going to be times X here minus 3 times X. And so for both of these fractions, the X's will reduce. And so what we end up with is -2 over -2 minus 3X. And I mean, one thing we can do is reduce by -1, or you can think of it as multiplying the numerator and denominator by -1. And that'd be 2 over 2 plus 3X is equivalent as well. So that is my positive function. Any questions on that? All right, let's start by finding the domain. So if we want to find the domain of F of G, what do we need to find first? The domain of what? G, because that's our inner function. So we need to find a domain of G. And so if we look at G of X, what's the domain there? X can't be 0 because you got an X in the denominator, and we don't want that denominator to be 0. Next, we're going to look at what is the domain of the function we found. Q over 2 plus 3X. So if we want to find the domain of that, what are we going to do? Yeah, we'll say 2 plus 3X can't equal 0. And we'll get 3X can't equal -2, so X can't equal -2/3. And so that means the domain of my composite function, I'll combine those together. So its domain is going to be X such that X can't equal 0, and it also can't equal -2/3. Any questions on that? No? All right. So one thing that's interesting that I haven't really talked about is I think you understand when we're doing, F of G of X, we're thinking about it like this, right? For it to exist, this needs to exist. So yeah, of course, X can't be 0. But if we think about the whole thing being defined, we want to make sure for F of X that this X wouldn't be 3, right? And what would make this 3? A -3 over 2. I mean, sorry, a -2 over 3, which is what we got. And so you can also think about it in that term. That's the way we actually used to teach it in the day, but I'm not a big fan of that. I really the other way. But just in case it helps somebody else out, if G of X was 3, we know that this would be undefined And so what would make this 3? Negative 2/3. You can also think of it that way if you prefer. It's just this problem reminded me of that. So I wanted to talk about it. Any questions on it? All right, let's talk about G of F. Just gonna bring this along for the ride as we go along. So G of F. And we're doing G composed with F of X. So everywhere there's an X in G, we're gonna put F of X. So this is gonna be negative 2 over F of X. It's gonna be negative 2 over X. Over X minus 3. And so just like we did before, I got a fraction within a fraction. I'm gonna multiply it by the denominator there to get rid of that. And I'm gonna do it to the denominator here, numerator here. In the denominator, it's just gonna cancel, but in the numerator, it's gonna distribute. And so I'm gonna have negative 2x plus 6 over x. Or if you want to write it as 6 minus 2x over x, that's fine too. Whatever works best for you. Any questions on that? Nope. So trying to find the domain of that, we need to look at the domain of the inner function, the domain of f, and so from there, we get that x can't equal what? 3. And then we need to look at the domain of the function we found. If we look there, x can't be what? 0. And so our domain of our composite function would be x such that x can't equal 3 or 0. Yep. Any questions on that? F of f. Oh, I think that's the worst one. I guess it's not that bad. So for f of f, f of x. So that means everywhere there's an x in f, I'm going to put an f of x. Notice there's 2 x's, right? So we're going to have f of x over f of x minus 3. And if you don't want to write this step, that's fine. I just keep doing it because, I don't know, it's easy for me. I get confused if I don't do some stuff, so that's one of the things I need to do. And so we're going to replace that f of x with what it is, which is going to be x over x minus 3 over x minus 3 minus 3. And just like we did before, we got fractions within fractions. Let's multiply by those denominators to get rid of that. So we're going to multiply numerator and denominator by x minus 3. And so here, reduce. It's also going to reduce with this one, but this negative 3 is going to distribute to that. So what we end up with is just an x in the numerator up there. We have that x from this term. And then that negative 3 distributing will end up with negative 3x plus 9. We just combine our like terms from there. So it'd be x over negative 2x plus 9. Or if you want to write it as x over 9 minus 2x. Either of this is fine. I don't know, I have like this weird compulsion to not have a negative as my first term. But they're both equivalent. So. Any questions on that part? Talk about the domain. Well, for this one, we look at the domain of f first, which is, we already figured out, is x can't equal 3. That's kind of what I like these problems, because you kind of have part of it figured out as we go along. And then we're going to look at the domain of the function we found, which is going to tell us that 9 minus 2x shouldn't equal 0. That 9 can't equal 2x, which means x can't equal 9 over 2. And so our domain here is going to be x such that x can't equal 3 and 9 halves. Any questions on that? Oh, sorry. I'm trying to find a spot to work. Maybe go this way. So the last one we're doing is g of g. We're going to do g, compose of g, is g of x. Which is, we're going to put a g of x everywhere. It says an x in g. So we have negative 2 over g of x. Which if we replace that with what g of x is, it's going to be negative 2 over x. I think these problems, the f of f and the g of g, are the ones that get people the most. It's just because it's kind of confusing to put a function within itself. But just step by step, take time, and it's the same little process from there. And so we got a fraction within a fraction. Once again, I'm going to multiply by x, numerator and denominator. And we're going to end up with, what? Negative 2x over negative 2. Is that right? That looks right. Which is just going to equal what? X. And so if we're trying to find the domain of this, first we need to look at the domain of the inner function, which tells us x can't be 0. So we know the domain of g, x can't be 0. We need to look at the domain of the function we found, which is no domain restrictions there, right? It's just x. No variable in the denominator, no variable under an even root. And so my domain of my composite function is to be x such that x can't equal 0. That's interesting. Any questions on that? So what does that tell us about G? I don't know. That when I do the composite of it with itself, there we go, I just get x. Yeah, it means that the two functions you're composing together are inverses of each other, which means G is its own inverse. And like I'm curious about it because, well, let's find it. Let's find G inverse just to see. So we're gonna take G of x is equal to negative 2 over x. And so we're gonna replace G of x with y, right? And y is equal to negative 2 over x. And then let's swap them. Let's switch colors when we swap them. So we'll have x is equal to negative 2 over y. I guess what we will do here is multiply both sides by y. I'm going to get yx is equal to negative 2 and divide both sides by x. Yeah. Y equals negative 2 over x. The G inverse is negative 2 over x. It is its own inverse. makes a lot of sense. The function of the form 1 over x is called the inverse function. I never put it together, and that's usual. It's interesting. Any questions on that? You're not gonna have a problem like that. I just thought it was interesting to see the connection. I didn't notice it until we're doing it. All right. So let's look at this. Maybe I'm too zoomed in. That's fine. So I got this graph of this function. It won't let me do that. Send it back. There we go. I got this graph of this function, and we want to find the inverse of it, the graph of the inverse function. So what is the graph of the inverse function going to look like? If I remember how to do that.
Switch the y to x.
Yeah, switch the y's and x. So let's start up here. So this one has the point 3, 4. So the inverse will have the point what? 4, 3. So 1, 2, 3, 4. 1, 2, 3. That's right here. 4, 3. The original function had 1, 2. So the inverse is going to have what? 2, 1. So 1, 2, 1. Kind of in the way here. And the inverse function, the original function has -3, 0. So the inverse function will have 0, -3. And then the last one, it has the point -4, 4. So it's going to be the same point. If the values are the same, then the inverse is going to share a point with your function. Because when you swap them, it'll be the same. And so our inverse function will look something like that. Notice it's symmetric to that diagonal line, y equals x, and it touches. So the other thing is if they have the same value, the point will be on the diagonal line. Y equals x. Of course, y is equal to x. So they're going to have the same value. Any questions on that? Nope. All right, which was this one? I want to go to an easier. This one's not bad. Just kind of zoomed in a lot. All right, so we got this function. It's 7 over 6 plus x. We're assuming it's 1 to 1. We want to find the inverse and then find the domain and range of both the original function and the inverse. So that one, a shot. So when we're trying to find the inverse, first thing we're going to do is what? We're going to replace the name of the function with y. So we're going to have y equal to 7 divided by 6 plus x. And then we're going to swap the x's and the y's. That's when we're actually finding the inverse. And so we're going to have x is equal to 7 over 6 plus y. And now the hardest part, in my opinion, we need to solve for y. And so, well, we got a fraction with the y in it, the variable we want to solve for. Let's multiply both sides by that denominator. And so we end up with what? 6x plus yx, or xy, however you want to write it, is equal to 7. And we want to get y by itself, so we have a y term on the left-hand side, a term without a y on the left-hand side. So let's subtract the one without from both sides to move it over. I'm going to have yx is equal to 7 minus 6x, and divide both sides by x. And so we'll have y is equal to 7 minus 6x over x. And then the last thing we gotta do, right, is it was f, yeah, f inverse. 7 minus 6x over x. Any questions on finding that? So let's talk about domain and range then. The domain of f is going to be what? X can equal -6 because we got 6 plus x down there in the denominator, so x can't equal -6. Oop. Grab the negative. Don't do that. And so that also tells me that the range of f inverse is what? -6. Just make sure that you do it in terms of y, right? Y cannot be -6. And so we know what's the domain of f inverse. X can't equal 0. You gotta x down there in the denominator, so you don't want it to be 0. And so that means that the range of my original function is going to be y can equal 0. Good. Which makes sense. If you look at this function, there's no way to make that 0 because for for a fraction to be 0, the numerator needs to be 0. Our numerator there is 7. Can't make that 0. So that does make sense when you look at it. Any questions on that one? All right, let's look for one good one to do. I think that's my capstone problem right there. So, yeah, f of x is equal to 2x over 3x minus 1. It's a 1-to-1 function. We want to find its inverse and then find the domain and range of f and f inverse. Huge problem. So, oh, that's fine. So, like before, first thing we're going to do, substitute instead of the name of the function, f of x, we're going to write 4. So, we're going to have y equal to 2x over 3x minus 1. Then to actually find the inverse, we're going to swap the x's and the y. Now, you're only going to have one instance of x now, but you're going to have 2 instances of y. And it's kind of a similar process to solve for y here than the last one. It's the only thing is we actually have a y in the numerator as well. So we're going to multiply both sides by 3y minus 1 again, or similar to last problem. It's a y. And so we're going to end up with 3xy minus x, when we distribute that x, it's going to equal this 2y. And so what I'm looking at is this term has a y, this term does not, this term has a y. So I want to get all my y's on one side. There's a few ways to do it, but probably the easiest way, I'm going to subtract 3xy from both sides. And so we end up with negative x is equal to 2y minus 3xy. And now that I have every term with y on one side, every term without it on the other side, this term has a y, this term has a y. I can factor y out. So I'm going to have negative x is equal to y times 2 minus 3x. And then isolate the y, get y alone. I'm going to divide by minus 3x. And we'll end up with, let's rewrite it the other order. So y is equal to negative x over 2 minus 3x. And if negatives bother you as much as they do for me, we can write that as x is equal to 3x minus 2.
Mm-hmm. The negative x equals 2y minus 3x. Why can't you just divide it by negative 2?
Here? So you're talking about just dividing this whole thing by negative 3? Well then.
Well, negative 3x to get rid of that.
So, but that's gonna. So if you did that, you would end up with this over negative 3x as well. Because if you divide a side of it, it's gonna have to apply to both terms in there. You can't just do it to one side. I mean, one term over there. You can't just do it here and here. It's gonna have to be this whole side. Any other questions? Right there. So let's rewrite it with the name. Whoop. So f inverse of x is going to equal x over 3x minus 2. Or negative x over 2 minus 3x. Either one's fine. They're equivalent to each other. Any questions on that? All right, so let's talk domain and range. So domain of f, range of f, domain of f inverse, range of f inverse. So what's the domain of f? Yep. You would set, we can do it real quick. 3x minus 1 can equal 0. Add to 1, so 3x cannot equal 1. Divide by 3, x cannot equal 1/3. So the domain of my original function can be x such that x cannot equal 1/3. What else does that tell us? Yes. So the range of the f inverse is going to be what? Y. So that such that y cannot equal 1/3. Good. What are we going to find next? The domain of the inverse. So to find the domain of my inverse, I know that 3x minus 2 cannot equal 0. So 3x cannot equal 2. And so therefore x cannot equal 2/3. And so I know that the domain of f inverse is going to be x such that x cannot equal, was it positive? Yes, 2/3. And that's also telling me what? The range of f is going to be y such that y cannot equal